Welcome to the first program in our series of Science and Technology Unleashed. My name is Rahel Ramzanli, and I will be your host for this episode. Maulana Hazrat Imam said that from the very beginnings of Islam, the search for knowledge has been central to our cultures. Join us as we explore how astronomy, medicine, artificial intelligence, robotics, and other scientific developments shape our world. Through this journey, we'll explore science, technology, and Islam's contribution to knowledge. We'll meet industry leaders, scientists, and experts in their fields from the Jamaat around the world. We'll try to understand how this new knowledge is changing our understanding of the universe and how the world may look very different from what we see now. Now let me introduce you to our first speaker today. Dr. Farah Alibay is a system engineer at NASA's Jet Propulsion Laboratory. Her work has focused on InSight Mars lander, as well as its companion mission, the Mars Cube-1 CubeSats.
My name is Farah Alibay, and I'm an aerospace engineer at the Jet Propulsion Lab here in Pasadena. It's one of the many NASA centers in the United States. So I was born in Montreal, Canada, but my family was born in Madagascar, and we're originally from Gujarat in India. I'm an aerospace engineer and have studied about 10 years to get here. So I have an undergraduate and master's from the University of Cambridge in England and a PhD from MIT in Boston. The way that I got started at JPL was through internships, actually. I did internships throughout my undergraduate, but when I came over to the US for graduate school, I did one internship at Goddard Space Flight Center out in Maryland, and then 2 here at JPL. And my first summer at JPL was the summer of 2012. I was in my second year of graduate school, and that's when JPL landed the Curiosity rover on Mars. It's a car-sized rover that we landed using a crane and dropped it down on the surface of Mars. And it was just so incredible to be there, to see the team make history happen, and to see them drive the rover around on those first few days on Mars. And you can't help it, right? If you see history being made and these extraordinary engineering feats happening, I was just in awe and decided, yeah, this is where I want to work. This is the team I want to work with. This is the type of work I want to do. I also want to change history. And so today I've been at JPL for almost 7 years, and I'm now part of the team for the Perseverance rover, which will be our next big rover that will be landing on Mars in February of 2021. So in the recent years, we've seen an explosion in interest in aerospace and in space exploration, which is really awesome for someone like me who's so passionate about this field, right? So I work in robotic exploration. I've mostly worked on Mars missions, although currently we also have missions that are being built to go out to Europa, which is the moon of Jupiter. We have missions all over the solar system. And our main goal at NASA and at JPL is to look for signs of life in the solar system, to look at whether there might be life elsewhere in the solar system. But what we're seeing across the United States and across the globe is an excitement for space. We have commercial aerospace now who provide us those rockets. We have U.S. astronauts launching from U.S. soil again. We have extraordinary missions being done out in Europe. And JPL actually just delivered an instrument for the JUICE mission, which is going out to Ganymede, which is another one of those cool moons in the outer solar system. So I think this field is only just starting. It's gathering speed, it's gathering a lot of enthusiasm, and what that's going to mean is more and more scientific discoveries, a better understanding of where we come from, and not only that, but a better understanding of our own planet. We at NASA also look at our own planet, our own oceans, our own atmosphere, and we learn from things elsewhere to understand how we might help our planet survive in the future. So I think that with any field or with any passion, really what it comes down to is what your curiosity is. So what I would encourage anyone to do when they're trying to look for a career path is to look at what they're interested in and pursue that, right? When I was a kid, I liked space, I liked tinkering around, I took things apart in my house and maybe never put them back together. My parents weren't so happy about that. But I was curious, I would ask questions, I would help my dad build things or fix the car to learn about what was happening. And that's where I got started, and that's really what led me to this field, because I realized that I had some skills as an engineer, I was good at physics, and I love space, and I put those two things together. So I think for anyone that's sort of looking for a career, I'd say don't worry too much about what the end of the road is, but for now, focus on what you love doing, because what it will lead to is a career that you love, and I love going to work every single day, and I just hope that everyone else could feel that way also about that job. Robotic exploration has always been a precursor to human exploration. So if we look at the original moon missions, for example, JPL, the place I work at, actually landed several landers on the moon before Buzz and Neil Armstrong ever went there, because they learned about how to land on the moon, how to get there, what the environment might look like. And right now, we're actually doing the same with Mars. So I'm working on the Mars mission Perseverance, which is teaching us a number of things about that planet. We're landing there yet another time. It is not an easy feat to land on Mars. But additionally, we're bringing instruments with us that allow us to understand the planet a little bit better. We have a weather station that will tell us about the pressure, the wind, the temperature on Mars, so that gives us local weather. We have that on different missions on the surface of Mars, actually. We also have a radar underneath the rover that looks below the surface of Mars and allows us to understand the composition if we ever want to build anything on Mars. And the coolest instrument that we have on Perseverance is an instrument called MOXIE. What MOXIE is going to do is it's going to take the atmosphere from Mars. So it has a really thin atmosphere that's not breathable for humans, but what it's going to do is it's going to extract oxygen from the atmosphere and show that you can extract oxygen and produce oxygen on Mars in situ, and that's called in situ resource utilization. And that's a huge stepping stone for eventually sending humans to Mars, because it would allow them to be self-sufficient on the surface of Mars. But for me, spending time in nature is also a relaxing time. It allows me to meditate, to be away from my cell phone, which I'm pretty much attached to the rest of the time. And it's really where I find my energy, because my work can be really demanding. So taking that break for myself is also very important to me. No, I don't think that, 15 years ago when I was a teenager, that I really knew that this is where I would end up. But one day, maybe closer to university, it clicked that there are societal pressures of where I might want to be, but there's also my passions. And I discovered that I could tie being an engineer, being a very accomplished professional person, and also following something that I think is really cool. So I'm privileged that maybe around the age of 17, 18, I figured that out before I went to university. And my parents were always very supportive of me. They did not have expectations. They just always told me, do whatever you want to do. Don't worry about what people say around you. But if you're going to do something, be the best that you can be at it and be a good representative in that domain. So that's how I ended up here. And I've had a lot of mentors along the way and a lot of people that have helped me along the way to get myself here. So it's not an easy journey. Definitely, I did not expect to be a 10-hour flight from where my parents are, and it's still hard sometimes to be so far away from family. But I also have so much happiness and joy that I'm doing something that I really am passionate about. So when you think of engineers, you often think that you have to be good at math and physics, and that's true, you do have to be good at those things, but really the most important things as engineers is to be good team workers, to be good collaborators, to be good at listening to other people on your team and at managing people. So my best advice for young students or children is to find what interests you and pursue that. So the best advice that I've ever heard given, in fact, is go to a library, go to a bookshop, walk around the aisles and see what you're drawn to. Where's the first place that you go look, right? And I can tell you the first place that I go to is the space section, or even, in the Lego store, I'll go look for the space shuttle or something like that, right? And so if you don't know what your passion is, first figure that out. And then my next piece of advice is, don't ever let someone tell you no. Don't let people tell you that you can't do something. So for example, when I was a teenager, my career advisor, when I told her that I wanted to be an aerospace engineer, and at the time I was thinking, do I want to be an aerospace engineer? I wanted to be a podiatrist too. And I thought, well, I don't really know what I want to do here. But I'm leaning towards engineering. And she said, well, engineering, it's a male-dominated world. I don't know if you'll be successful there. I don't think it's a career for you. And even though she meant well, at the time, that could have turned me away from what became a beautiful career. Now, me being me, of course, I was like, no one tells me what I can't do. Like, let me go do what I want to do. And I became an engineer, and I'm very, very happy.
Well, I hope you found that as fascinating as we did. Landing a rover on Mars is really quite something special. We can only imagine the hard work and planning it took to make this happen. Now we move from Mars to think about the rest of the solar system and beyond as we hear from our next guest, Dr. Farzana Miru. Farzana is an astrophysicist working on helping to get a better understanding of the universe and its contents. Farzana reflects on her journey, the role of mentors, and the support she has received from her parents to get where she is today.
My name is Farzana Miru, and I'm an astrophysicist and a lecturer at a university. So my research involves trying to understand how planets form, trying to understand how big planets like Jupiter could have formed. And the way I do this is to run really large-scale computer simulations using what we call supercomputers, big computers that we can run these simulations on. Planets form in something called protoplanetary disks. These are disks of gas and dust that surround a central star. The sun would have had a disk of gas and dust around it, one of these protoplanetary disks around it, many years ago. And it was out of this disk of gas and dust that the planets in our solar system formed. One of the reasons why I'm so excited about this area of research is because essentially I'm venturing into the unknown. I'm trying to understand something that we don't know yet, and I'm trying to understand the mysteries of the universe, and that's something that excites me a lot when I'm doing my work. 30 years ago, we did not know of any planets outside of our solar system, but now we've detected over 4,000 extrasolar planets. These are planets that are outside of our solar system. This field has moved incredibly fast in the last 30 years. We are even just started detecting planets in their birth environment, in their protoplanetary disks. And as we develop more and more instruments in the future to be able to detect planets, we will no doubt be able to understand how planets form. And also, in addition to that, we will really move forward with trying to understand whether or not life is out there in the universe. My path was not so straightforward to becoming an astrophysicist. I did not know when I was really young that that's what I wanted to be. I was always interested in physics, I was interested in astronomy, I always enjoyed problem solving, but I never actually knew what I wanted to do. So I always kept a very open mind about what I wanted to study and what I wanted to do. So at university I chose quite a broad degree where I got to study chemistry, physics, maths and computer science in my first year. And then as I went through the years, I started specializing more into physics and maths and then into astrophysics. But I can think of certainly two examples in my journey that actually really told me that astrophysics was the thing that I was interested in. The first story is when I was at the end of my second year of university. We had just come out of our final exams. It was a maths exam, and I knew that I needed to achieve a particular grade in my maths exam in order to be able to study astrophysics for the next 2 years, which is what I had chosen to do. Now, this was our final exam of the year. Everybody came out absolutely ecstatic because it was the final exam and they didn't have to work anymore. And I came out absolutely in tears because I thought I had not done well enough in that exam to be able to study astrophysics in the next couple of years. The second time in my life when I think I really understood that I wanted to study astrophysics was when I had graduated and I was working as a business analyst. So I still at that stage hadn't figured out that I actually wanted to be an astrophysicist. I remember sitting at my desk at work one day and I was thinking about the fact that 1 year before I had been doing a really interesting master's research project on how planets form. And I remember sitting at my desk at work thinking, that was really interesting what I was doing a year ago, but what I was doing right now didn't give me the same level of excitement that that research project did. So that was another moment of realization that I really wanted to study astrophysics. Some people might say that, well, I spent 10 months working as a business analyst and that wasn't something that I ended up going into. You know, does that feel like a bit of a waste of time? I would say absolutely not, because those 10 months told me what I didn't want to do and also what I did want to do. And when I finally figured out what I wanted to do, I knew that I was far more passionate about astronomy than I had realized before. I went into it with more passion, with more motivation, and I knew what my end goal needed to be. And so that's what I would say, is that if you do have the opportunity to get a number of different experiences, then that is incredibly valuable, whether they are positive, whether they are negative, and along the way you will learn something and you will gain new skills as well. I often like to tell this story about my journey to young people because I feel that it provides some comfort for those people that don't know very early on what they want to do, and that it's very much okay to explore, to try and figure things out. And the important thing is that you build up your skills and your experience in the process of figuring things out. Parents have a huge role to play in their child's path. And the important thing is that parents do not need to be an expert in the areas that their children are interested in. So my parents are not astrophysicists. But what was important was that they encouraged me to have an open mind. They encouraged me to explore, and they encouraged me to read around the subject, to try and explore the different areas that I was interested in. My parents also didn't push me into doing any one particular subject or another, but they supported me with whatever I chose to do. I remember when I was young, my dad used to drive me around to different cities where he would take me to talks that were being held by amateur astronomical societies in nearby cities, and we would go and we would listen to really fascinating talks. My dad didn't know back then that I would become an astrophysicist, but he knew that that's what I was interested in when I was young, and so he supported that passion and he supported that quest for knowledge, and and instilled that curiosity in me. And so the fact that my parents were open-minded really meant that I was able to have the freedom to explore and figure things out and really try to understand what my passions were. It has been really important for me to have a mentor, to have several mentors, because you benefit from their wisdom. They have been through this path before, or they may have been through a similar path before, and they can tell you about some of the things that you should do, some of the things you shouldn't do, and so there is no point in trying to navigate a career path by yourself, learning everything from scratch again, when instead you could really benefit from the wisdom that that your mentors could provide. I highly encourage children to seek out mentors, and for parents, if you see that your children are inclined towards one field or another, then help them seek out mentors, because they can use the benefits of what those mentors have been through already to help propel them forward in the future. There are two general bits of advice that I can give to the youth. The first is that I think you should seek out every opportunity that you can. Grasp every opportunity that's given to you, because every opportunity gives you new experiences. So don't let a summer holiday go by where you don't go out and get some kind of experience, whether that's work experience, some kind of voluntary experience. Remember, voluntary experience within our community is also incredibly valuable experience that you can use to help build up your CV, and all the experience that you have together will then mean that you will have a strong CV. The second bit of advice that I would give is that you should develop your skills all the time. Take up a new hobby, learn something new, do something that develops your skills, that challenges you in different ways to how you've been challenged before. The world of work will be very volatile, it will be very dynamic, and the best way in which you can navigate that is to develop a variety of skills that will mean that you can that you have the skills to be able to work in a number of different areas in the future.
In his LaFontaine Baldwin Lecture in Toronto in 2010, and again in his address at Harvard University in 2015, Maulana Hazri Imam explained that this cosmopolitan ethic, this readiness to accept the complexity of human society, and indeed the amazing diversity of creation itself, flows directly from the spiritual core of Islam.
In acknowledging the immensity of the divine, we will also come to acknowledge our human limitations, the incomplete nature of human understanding. In that light, the amazing diversity of creation itself can be seen as a great gift to us, not a cause for anxiety, but a source of delight.
In our next segment, we explore the role of science in Islam.
Very soon after the birth of Islam, leaders of all stripes, caliphs, princes, even regional governors, began encouraging and investing in far-reaching scientific efforts to systematically observe, deduce, quantify, and comprehend the laws, the order, and the harmony that was apparent in the workings of the physical world. The impetus for this quest came from the Holy Quran itself. Indeed, in most schools within Islam, and especially in the Shia tradition, the human intellect is recognized as a precious and divine gift. Muslims are enjoined to reflect upon the divine signs, ayats, whether they are found in the revelation or in the natural world. The Fatimids, the Abbasids, the Umayyads, three of the most important Muslim dynasties, established vibrant cosmopolitan centers of learning and research. The Muslim scholars systematically translated the entire corpus of the then known knowledge into Arabic. They also added to the knowledge base by revising existing scientific treatises, conducting their own experiments, and amending any inaccuracies. Patrons established libraries, observatories, laboratories, and institutions of learning, inviting scholars from around the world. Of all the sciences, astronomy was, within the Islamic tradition, held in especially high esteem. To quote the astronomer Al-Batini, astronomy is the most noble of the sciences, illuminating to the soul, pleasing to the heart, a field of endeavor with an invigorating effect on the intellect, and one that uniquely offers opportunities to unveil the very mysteries of the heavens. When one looks out to the horizon during a beautiful sunset, or looks up at the moon in the evening sky, one recognizes that the stars and heavens continue to captivate the imagination of the mind and the curiosity of the soul. In keeping with this spirit of inquiry, we have invited and heard from some of the world's best researchers to inspire and challenge us to see the world anew, to share with us the excitement of discovery at the very edge of human understanding, and, in the process, spark the imagination of the next generation of explorers and innovators.
In the final section of the show, we take a look at some of the latest news in the fields of science and technology, narrated through artificial intelligence. This is our hand-picked selection of stories covering emerging technology and trends in this digital age.
Amazon have developed palm recognition technology called Amazon One. The technology uses the human palm as identification, linking the details of the palm to the person's account. Amazon plans to offer the service to third parties such as retailers, stadiums, and office buildings. Palm identification was chosen over other biometric alternatives as a person's identity can't be determined by just looking at an image of their palm, and it requires someone to make an intentional gesture to hold over the device to use it. Google has developed a service called Hold for Me, which uses AI tools to taking over as an automatic secretary when on hold to a call center, leaving the user free to put down the phone and carry on with their life. The service will listen out for when the call is picked up and send a notification when it's time for the user to get back on the phone. Toyota has unveiled some of its futuristic mechanical helpers. One of the robots hangs from the ceiling so it can complete tasks without adding to the limited floor space in many homes. Another robot that was demoed had a soft bubble gripper that was able to grab a variety of objects using air-filled cushions. Toyota uses virtual reality to train the machines, getting a human to perform actions and then programming the movements into the robots. At the moment, these robots are still prototypes. Nanotech tattoos can signal changes in a person's biochemistry, warn wearers of radiation exposure, or detect the presence of UV light. A tattoo that warns users to wear skin protection if there is too much UV light uses a UV-activated dye inside of a plastic nanocapsule. After they are applied, the tattoos are invisible until they are exposed to UV rays, at which point they turn blue. The scientists are also working on temperature-sensitive inks to use as thermometers. Wearable temporary electronic tattoos can be used for sensing electrophysiological signals as well as for controlling mobile devices. They are much less permanent than traditional tattoos, but they can use battery-powered electronics. Researchers at the University of Helsinki have used artificial intelligence to create a system that translates signals from the brain into images of what the person is thinking of. Research on brain-computer interfaces has so far been limited to simple actions. Using machine learning enabled the researchers to create a more flexible, adaptable system. The researchers used a generative adversarial network to train the system by having participants focus on different areas of images and then validating the computer-generated response. The results from the experiment show strong evidence that the method is highly effective.
As we heard earlier, Al-Battani once said, "Astronomy is the most noble of the sciences, illuminating to the soul, pleasing to the heart, a field of endeavor with an invigorating effect on the intellect, and uniquely offers opportunities to unveil the very mysteries of the heavens." Thank you for watching from across the globe. We look forward to seeing you next week as we continue our journey with science and technology unleashed.